you all very much, and a big thank you to Jetro for inviting us here. With my colleague Keenan Weberbeck, we're going to tell you about a platform for personal robotics. I'm particularly honored to be invited to speak after Richie Yamada-san, who's in the world of technology and engineering. He's one of the rock stars. I'm very honored to speak after him. 2 years ago, we visited IREX at this very conference. And at that time, we were just starting our company. We were just starting a personal robotics project. Eric Berger and Keenan Weberbeck joined from Stanford University with a vision, and their vision was to build a personal robot. They had already built a prototype at Stanford called the PR1, and they came to Willow Garage to build 10 or more of the PR2 robots and make it a platform for research and development. The goal is grand. The goal is to create and help accelerate a new industry in personal robotics, very much of the sort that Chairman Yamada mentioned. So what do we mean by a personal robot? For us, a personal robot is a human-scale device that is designed to manipulate objects and help people. It has to move around in the environment, and it has to be able to grasp and manipulate objects that are typically found and used by humans, by people in homes and offices. Personal robots are also called mobile manipulators, or service robots, or partner robots. There's been very much great work in research labs and companies' research labs over the last few years. And in this slide I show pictures of a number of famous robots, many of which you may recognize. And these robots are very exciting as initial steps into what could be a personal robot. But what are the barriers to creating an industry? And what will that industry look like? We look at the industry of robotics, and coming from Silicon Valley, our bias is that the industry will look like the computer industry, with different companies providing different layers of functionality to customers. So some companies in the computer industry provide hardware, some provide software, some provide applications on top of that, and some companies package the whole thing into consumer products. So we use the term personal robots to suggest an analogy to personal computers. And let's look at the PC industry for comparison. So in the personal computer industry, there are applications that are really the reason people buy computers. You can't have applications without computers, but you can't sell computers without applications. So spreadsheets, desktop publishing, email, all correspond to what the applications for personal robots would be. At the system software level, there's the operating system, something like Windows or Linux. There are developer tools. It's like C compilers and make systems and other ways that you actually build the software. And then there are libraries of components that application developers can buy or download from the internet, put together in order to create high-level, powerful applications. And finally, at the hardware level, we obviously have the computers, the things that you can actually see and take pictures of. What's interesting about the hardware level in the personal computer industry is that it's not locked to a particular operating system. And if you look historically, whenever it has been locked to a particular operating system, eventually it got unlocked, right? So when you have, IBM used to have its own operating system on mainframes, but now it runs Linux. Apple hardware used to only run Apple software, but now it can also run Windows. All Apple software and Microsoft software, both and Linux, all run together on most common hardware. Another aspect of hardware is that they're open interfaces. Open interfaces doesn't mean that the hardware is free, and it doesn't mean that the specifications are published so that anyone can go off and build it. But what it means is there's a standard way to add a hard disk, to add expansion slots, PCI, USB. There's lots of standard ways to extend the system in order to help application developers deliver what customers really want. And so that ability to use third-party components It's very much like in the automobile industry, where you have some parts suppliers that are creating different parts for automobiles. We also look at what are the applications in the personal robotics industry. So the robots that Eric and Keenan designed, and when you start to design a robot, you have to think, well, what are the tasks this might want to be used for? The goal here was to have a wide range, so to create a platform on which we could explore applications for aging and disabled populations. So for example, being able to carry objects. Computers are particularly good at memory, so remembering where things are, retrieving those items, preparing food, cleaning, and in other ways helping people to live longer lives independently. In service and operations, there are many examples. Pick and pack, stocking store shelves, tracking inventory, retrieving items, doing flexible manufacturing, where you have an assembly line that maybe does different things all the time. And finally, retail automation. I think all of those areas are also areas where personal robots can be used. And finally, around the house, dishes, doing the dishes, tidying up, doing the laundry, cleaning, organizing. All these are applications where robots can be interesting, and Chairman Uchiyamada actually pointed to many of them in his talk. So those examples suggest some possible applications for personal robots. But back to our PC analogy, which came first, the spreadsheet or the PC? And this is not a chicken and egg question, right? This is an easy answer, right? The PC had to come before the spreadsheet. Before there was a PC, a personal computer that the spreadsheet designers could play with, there was no spreadsheet, there was no concept of a spreadsheet. Only when there was a platform on which to build the applications could the applications start to begin to exist and then be refined. So when we look at the industry and we ask the question, how can we speed up the time until this industry really takes off, and how can we help? The answer is, look at how things are done today. We start a project, almost every company and research lab builds its own required hardware, and then writes the support software for it. And finally, at the end, you can do advancement. This is a model that will cause us to take a long time to get to where we're going to have a real personal robotics industry. Instead, what we'd like to see is the project starts and everything can advance right away. In order to do that, we have to have a platform available that the developers can simply acquire and start to use. So, the applications in personal robotics remain to be explored. The system software and the hardware are what we at Little Garage are looking at. We have ideas of the applications that we're aiming for, but we're really interested in how do we build a community and a foundation that everyone can use to work together. And so the systems that we're building are called ROS, or Robot Operating System, corresponding to the early operating systems and tools in the PC industry. And the PR2 is our offering as an initial robot that we hope will be made available for many different research labs and will be a common platform so that researchers can work together. So, for the rest of this talk, my colleague Keenan Weiberbeck is going to focus on the ROS and the PR2 aspects. Keenan is a hardware engineer and someone who has designed the PR2 from the ground up. And so it's my great honor to introduce him and let him talk about ROS and PR2. Thank
you. I'm very pleased to be introducing these exciting platforms to you. Our open source robot operating system and the PR2 robot hardware platform for mobile manipulation applications. I'm going to start with ROS.